Okay, imagine this scenario. You are in an emergency room, the clock is ticking, and a critical image, let's say a chest x-ray, has just been taken.
Right.
That moment, between the scan finishing and the doctor getting the final answer, that's always the bottleneck.
It's the ultimate bottleneck.
Now, what if there was a technology that could shave 30 seconds off that step? Every single time. Hundreds of times a day.
30 seconds sounds small, but it's not.
Not in that world. In that high-stakes environment, 30 seconds isn't just a minor gain. It is a genuine, measurable lifeline.
It absolutely changes the calculation. In the emergency department, speed translates directly into faster treatment decisions.
Yeah.
It's about escalating care or, just as importantly, ruling out something severe.
And that friction, that delay, it costs time, energy, and, potentially patient outcomes.
Exactly.
And that's the subject of today's deep dive. We're talking about generative AI as the engine for what we're calling the 30-second revolution, specifically in emergency radiology.
And this isn't some far-off theory. This is happening right now.
Yeah. So our mission today is, well, it's pretty straightforward. We're going to give you, the listener, a really practical breakdown of this new workflow.
Not just what the AI does, but how it does it. What are the quantified gains? And crucially, what are the limitations? We have to understand where the human stops and the machine begins.
And how they collaborate. And to set the stage, we can look straight at the source material, which points to a specific example from Northwestern Medicine. This is where the future has kind of already arrived. This isn't a lab experiment. It's their real day-to-day operating environment.
They've proven this is attainable right now.
Okay, so let's unpack this quantified speed revolution because the numbers are genuinely remarkable.
They really are.
The chief of emergency radiology there, Dr. Samir Aboud, he was already working at a blistering pace. Before this AI integration, he could read a standard chest x-ray, analyze it, and dictate the whole report in about 75 seconds.
Which is incredibly fast. 75 seconds for a full analysis, cognitive synthesis, and dictation. That takes years of training. It's a very, very high bar.
A super high bar. But the gain they achieved with generative AI it blew that baseline out of the water.
Yeah, the time per report plummeted. It went from that 75-second benchmark down to just 45 seconds.
45 seconds. So you're saving 30 seconds on a task that already took just over a minute. That's a 40% reduction in time per report.
A 40% reduction. That is a seismic shift.
And that's where the efficiency really starts to multiply.
Real exponentially.
Yeah.
What's so fascinating here is how that 40% aggregates. Think about it. An emergency radiologist in a busy hospital might review hundreds of images in a single 12-hour shift.
Okay.
So if you save 30 seconds on, say, 100 images, you've just freed up 50 minutes.
50 minutes.
If you save it on 300 images, you save 2.5 hours.
2.5 hours. That's time that doesn't just disappear. It means something fundamental for the doctors. And the source material highlights this crucial benefit. They call it less dictation fatigue.
Right.
Let's define that. What does eliminating dictation fatigue actually mean in a place like an ER?
It means removing the repetitive load, both cognitive and physical. Just saying the same standardized phrases over and over again.
All the boilerplate text.
Exactly.
Okay.
Every report has it. Describing normal anatomy, standard units, legal disclaimers. It all takes up mental bandwidth. When you automate that part, you let the human brain focus its finite energy on the genuinely complex work.
So we're talking about less mental burnout at, hour 10 of a long shift.
Precise.
And more capacity to really dig into the complex cases. The polytrauma patient, the subtle finding, the case that needs an immediate call to the surgical team.
It sounds like an efficiency boost that directly targets safety and physician well-being, both at the same time. If the machine handles the structured, repetitive drafting, the doctor conserves energy for true pattern recognition.
But that leads to the central question, doesn't it? Is this really a net gain, or are we just pushing that saved time into scrutinizing the AI's draft?
That's a highly critical question. And if the AI was just giving you raw data, then yeah, it might be a wash. But this system works because it's built around the concept of human-in-the-loop AI. The AI isn't just spotting things. It's using LLMs, large language models, to craft the output in standardized medical language. It's ready for review.
So the doctor is reading a coherent, structured document, not just raw code or something.
Exactly. It handles the heavy lifting of syntax and formatting.
And that phrase, human in the loop, that seems to be the non-negotiable term here.
It is.
It stresses that this is not about replacing the doctor, it's about augmenting them. It's about speed and consistency, but keeping that final judgment firmly in the human domain.
Right, and we can walk the listener through the exact steps from the source material. This three-step workflow is really the key to understanding the whole collaboration.
Okay, let's do it. Step 1, the scan. Pretty simple. Patient gets the X-ray, the image is captured and instantly fed into the AI system.
Step 2, the draft. This is the generative power. The AI instantly analyzes the image, computer vision, and at the same time uses an LLM to draft a comprehensive initial report.
And the sources emphasize that this step happens. What, faster than a human could even open the dictation software?
Faster than they could start articulating a single sentence. The speed is built on processing structured data at machine speed.
Wow. And then the irreplaceable part, step 3.
The check. The doctor or Dr. Abode, any radiologist, reviews the AI's draft. They're checking for accuracy, of course, but more importantly, they are integrating the full clinical picture.
The full context.
Yes. They make any necessary tweaks, ensure it aligns with the patient's history, and only then do they sign off. And that's the moment an AI suggestion becomes a legally binding medical record.
It's the ultimate high-speed assistant model.
That's a great way to put it. The machine provides the speed and the drafting, handling the repetitive cognitive load. The doctor provides the essential judgment and context.
So this hybrid approach, this is the gold standard for efficiency that the sources are talking about. It leverages the machine's strength, speed, and pattern recognition while mitigating its biggest weakness,
Which is the lack of that holistic clinical context.
the only way to safely get a 40% time reduction is by making sure that time is saved on the mechanical drafting part.
Not on the critical judgment phase. Absolutely not.
Okay, so that's the clinical side, analyzing bones, organs, the visual proving ground. But what's really fascinating is that the source material shows this technology isn't just staying in the reading room.
No, it's moving.
Beyond the diagnostic suite, where does this efficiency engine pop up next?
We have to shift focus to what the sources call the silent beneficiary,
Which is?
the massive administrative back end of the hospital. We're now using this automation engine to tackle bureaucracy, which is a huge friction point in modern healthcare.
And the specific problem they're gearing it up to solve is fighting insurance denials.
Exactly. For anyone who hasn't had to deal with it, an insurance denial is this notorious bottleneck in American healthcare. It consumes immense amounts of human time.
And it can delay patient care, lead to unexpected bills.
Yeah,
It's a mess.
it is. And denials usually happen because of these tiny discrepancies. A procedure wasn't pre-authorized correctly, or the billing codes don't quite match the doctor's notes.
And people spend hours trying to fix it.
Hours. Painstakingly reviewing dense policy documents, stacks of paperwork, just to overturn a single denial.
And this is where the same generative AI becomes an administrative powerhouse. So what's the mechanism? How does it solve this bureaucratic headache?
The mechanism is really elegant. It's an application of natural language processing, or NLP. When the radiologist signs off on that report in step 3,
The 45-second report.
right, the AI immediately extracts the structured clinical data, the finding, the patient's condition, the procedure, and then it uses that data to instantaneously cross-reference codes and policy data.
So it's translating. It's translating the medical truth into the administrative necessity.
Perfectly put. It takes the description of, say, a broken arm and ensures the billing codes for the X-ray and the treatment all align perfectly with that specific insurance company's policies.
It creates the paperwork to satisfy the payer right as the medical work is finishing.
Yes. And the ultimate goal here, it's not just about reducing costs for the hospital. It's about drastically reducing that administrative burden that leaves patients in limbo. Imagine getting clarity on your treatment coverage almost instantly.
This all sounds incredibly compelling. Instant diagnosis, less doctor fatigue, instant administrative approval. But we have to adjust the limitations.
Absolutely. The reality check is paramount.
We've seen enough with generative AI to know no system is perfect, not when it's deployed at this speed.
That's why we have to reinforce that core principle from the source material. AI proposes, the doctor disposes.
The ultimate responsibility, ethical and legal, rests with the human.
Always.
And we know this tech is still under constant scrutiny for hallucinations and edge cases. In medical imaging, those errors aren't just typos, they're real clinical risks.
They are.
Can you give us a sense of what a dangerous edge case might look like in radiology?
Sure. I mean, one of the biggest challenges is that context problem we touched on earlier. An AI might spot a dense area on a scan and quickly generate a report suggesting a new mass.
Okay.
But without the human context, It might fail to differentiate that finding from, say, a known surgical artifact from 10 years ago, or scar tissue that's already documented in a chart the AI hasn't fully synthesized.
So the AI sees a pattern, but the human sees a history. The machine can spot an anomaly, but only the doctor can place it correctly in the patient's timeline.
Exactly. Another big challenge is subtle artifact interpretation. A machine might misinterpret patient movement during a scan, which creates visual artifacts as a genuine clinical finding, or vice versa.
Right.
The radiologist doesn't just look at the image. They connect it to why the patient is there, their other conditions. They understand the physics of how the image was made. That holistic synthesis is just beyond the machine right now.
Which makes that human check indispensable.
Totally indispensable.
So what does this all mean for the future of emergency medicine? I mean, the 30-second revolution, it proves that real, safe efficiency comes from collaboration.
Intense, measured collaboration. The AI handles the speed, the drafting, the bureaucracy.
And the human provides the context, the history, and finally, the clinical judgment that prevents these life-threatening errors.
It's a powerful and, I think, a necessary partnership. And as we look at the source material, celebrating freeing up 40% of that routine workload.
Eliminating dictation fatigue, saving all that aggregated time.
It leads to a really fascinating final thought for you to consider.
Go ahead.
If the role of the emergency radiologist is fundamentally changed, if you free them from 40% of their core, repetitive work.
What entirely new or unexpected roles might emerge for these highly skilled professionals in the next few years?
Exactly. Will they now be required to spend 40% more time on interdisciplinary consulting, maybe leading critical care meetings or reviewing complex cases across multiple departments?
Will they evolve from being, image readers to being integral clinical workflow designers?
We've only just begun to scratch the surface of the downstream effects of this kind of radical high-speed efficiency game.
Something powerful to mull over as we close this deep dive.